Hey there, welcome back. So I've waited a long time in order to record this video, since this video is going to be one of the most important videos in this entire course, because in this video I'm going to talk about how an entire neural network is trained from scratch. So we are going to take an example dataset and we'll pass it over a neural network, and we'll find out that what really happens in each of the different steps, and how do we finally get the trained neural network. So let's get started. So here we again have a very simple problem which we have already encountered in past, which is the problem of sentiment classification. So you have a data set. In that data set, say you have just two features, feature 1 and feature 2, and you have values for those features, and you also have a sentiment column which basically contains the sentiment of that specific row, right? For example, the values of feature 1, feature 2 are for the first row is A1 and B1, and the sentiment is positive. Similarly, the sentiment corresponding to the second row is negative. So like that, you have a data set, and now what we have to do is this data set has to be fed to a neural network. So basically the data of this feature 1, feature 2 will pass through a neural network, and all the operations which happen in a neural network will take place, and finally we'll have some output, and the output will have two probabilities, one probability for positive and one probability for negative. Whichever has the highest probability, that will be basically the prediction, right? Okay, so let's first have a recap of what we already know. So this, as you can see, is the neural network architecture. So we already know what is there inside a neural network, right? We know that a neural network consists of multiple different layers. In each layer you have the different neurons, and these neurons are also interconnected. So basically neurons of one layer are connected to the neurons of the subsequent layer. And we also know that what are the visible layers and hidden layers and so on. So this first layer is basically the input layer, where you feed in the data, and then some operations would happen over here, the affine transformation and the activation functions, and then it passes the output to the next layer. So like that, the next layer also does pretty much the same, and it passes the output to the next layer, and finally from the output layer we get the two probabilities, right? For two classes, like in this case we have two classes, so we get two probabilities. If there are more classes, we get more. So apart from this, we also know what a single neuron is. So we know the mathematical function behind a single neuron. We have already talked about affine transformation and activation functions. We have seen that a neuron is basically a function which takes in some input parameters in the form of say x1 to x4, and it applies those functions, and it finally produces an output which it passes on to a subsequent neuron. Now there's also another thing which we know, and that is the connection between two neurons, right? So here we have this neuron and we have this neuron. So the connection between these neurons, which is basically this edge, so this is also associated with a weight, right? And when these neurons have a great bond, or I should say a very strong bond, then the value of that weight is high, right? So each of these edges that you see, these are also having a weight value, right? And apart from weight, there are also biases. So except the neurons in the first layer, all the neurons in the neural network, starting from this neuron to this, and all the neurons in the subsequent layers and everything, so all of them contain a bias term as well, right? So we have two different parameters for our neural network, one being the weights which are associated to each of these different edges, and then we have the bias terms which are associated to the different neurons. So now again we are back with the problem that we have to solve. So we have the data set where you have feature 1 and feature 2, and we have the sentiment column. So now first what we'll do is we'll just convert feature 1 to x1 and feature 2 to x2, just for simplicity, and sentiment to y. And now the thing is that now we just have to pass x1 and x2, these two features, to the feature values to the input layer, and then all those things happen, right? So this is pretty much how the things look now. So instead of the data block over here, we are passing on this the values for feature x1 and feature x2, and as you can see that in the first layer now we just have two neurons. Now why is there two neurons? Because we already know that the number of neurons in the first layer of the neural network should be equal to the number of features in your dataset. Now this is something I've talked a lot of times, right? So here in the input layer we have 2 neurons since there are 2 features. And why is that so? Because each of these neurons will accept will accept different inputs, right? For example, this neuron will only accept values for feature 1 and this neuron will only accept values for feature 2. So similarly, if you had more features, then you'll have more neurons and those neurons will be connected to the subsequent features. Now these are connected over here, and again the outputs are connected to the next like hidden layer in neurons and so on, right? So this is one part which is already clear to us. And finally, you can see that the output layer also contains 2 neurons. Now the reason being we have 2 classes which are positive and negative, so we'll basically get 2 probabilities. So it's a classification problem, right? So in the output layer we are going to use a softmax activation function along with the affine transformation, and we will finally get the probabilities for each of the different classes. And this is the the same thing from a single neuron's perspective. So this is basically how the connections look for a single neuron. So from feature x1 you can see that it's fed to the first neuron, and then the outputs are fed to the subsequent neurons in the first hidden layer. So this is the process in which the entire neural network is trained. So here you can see that like step by step everything is there. So let's just go through it once and then we can go through it visually as well. So the first thing that happens is you initialize all the weights in the network before training. So what do you mean by initializing all the weights? Now this is not just weights, rather it's initialize all the weights and biases. So I have already talked about, right? So in each of the edges, like where you have a connection between 2 different neurons, so in each of those edges you have a weight value, right? So like that, like there are many different edges in this entire neural network, and all those edges will contain a weight value. Similarly, for each neurons as well, you have bias values, right? So all those weights and biases need to be initialized. Now, how do you initialize them? Do you initialize it to 0 or what do you do, right? How do you initialize? So there are many different ways in which you can initialize. The most common way is a random, like picking all the values of weights and biases from a random distribution or a random normal distribution like that. And if you are doing transfer learning, you can even get the values of weights and biases like which are already pre-trained values and so on, but like that is totally out of scope for this video. But still, just know that there are many different ways in which you can initialize, and the way we are mainly going to initialize is taking the values from a random distribution. So you do the thing first, so you have all the weights and biases initialized, and now you have to iterate over the dataset and pass one row at a time through the network. So you are basically starting, like in the dataset, say you have 100 different rows, right? So you start iterating over the dataset. So you pass one row, right? You pass one row and the value of the first row is passed. For example, if you remember, then in the first row of this problem, the first row contained the value of A1 and B1 for the feature 1 and feature 2, right? So the values A1 and B1 are passed through the network. Then all the things happen, right? Like affine transformation takes place in different neurons, activation function takes place in the different neurons as well, and like that, everything just feeds forward through the entire network, and in the output layer you basically get 2 different probabilities. Now this thing happens for each row. Now for example, let us start with the first row. So in the first row you passed A1 B1 and you just passed those values through the entire network, and finally you have the probabilities in place. So what do you do after that? So after each row is passed, you do the following, right? You calculate the loss. Now how do you calculate the loss? Now there are many different ways in which you can calculate, and there are also many different loss functions which are available. There is like mean square loss which is there, cross entropy loss is there, so there are all these different loss functions which are already available for you for consumption. Now for example, right now let's not go over what are the syntax or how the different loss functions are calculated and so on. Just understand that you need to calculate a loss function, right? The loss function can be like of anything of your choice, but what it will give you, it will give you a value of loss. So you will basically pass the values of the probabilities which you have received. For example, for positive you have received 70%, for negative you have received 30%, and you will just pass those probabilities to a loss function, and that loss function is going to give you a value of the loss. And now what you do is you need to finally use the loss in order to change the values of weights and biases such that the value of the loss should minimize. Now we know that neural network, like when a neural network has a higher value of loss, that signifies that you have a wrong prediction, right? Your prediction is not correct. Now what your end goal is basically to minimize the loss, because when you have the least amount of loss possible, then you have the best neural network which you could have trained, right? So that is your end goal, and that's why you should always go towards the minimization of loss, that direction of minimizing loss. So how do you do this? How do you tweak the values of weights and biases to minimize the loss? So the process in which so basically what you do is you calculate gradients. So you have the loss. Now using the loss, you calculate gradients for all the different parameters, right? So once you calculate gradients, then you will feed in those gradients to some formula in order to change the values of weights and biases. Now this entire process of calculating gradients using the loss which you have, so using the loss function, and also tweaking the values of weights and biases, this entire process is called backpropagation. Just remember this term, that entire process is called basically backpropagation. Now the details of how the gradients are calculated, and how the loss is calculated, and what is backpropagation in detail. So these are things which I'm going to be talking about in the next section. But till now, just know that these are things which just take place, right? So now coming to this point, so you iterate through the dataset n number of times. Now when I said that you iterate over the dataset and pass one row at a time, so say you have 100 rows and you're passing one row at a time, so you're basically going through 100 different rows, right? So the iteration takes place 100 times. Now after 100 times, you basically have completed one pass through the dataset, right? You have completed one pass, since you have passed through all the rows which were there in the dataset. Now we don't really pass we don't just train for one time through the dataset, rather we train for multiple times. It can be 100 times or 1000 times through the dataset, anything is possible. So this term n, right? So the number of times you basically pass through the dataset, this is called the number of epochs. So this is again a neural network terminology. So the number of times you pass through your dataset while training is called the number of epochs. So this is pretty much the entire training process of the neural network. So now let's just take one row at a time and see it visually how it all really happens. So this is again the neural network architecture. So initially, just for simplicity, what I have done is, say for this entire neural network we have a weight tensor, and this weight tensor basically contains, this is a multi-dimensional array, you can say. So in this multi-dimensional array, for each of these edges, whatever is the weight values, everything is represented, right? So as it's multi-dimensional, so it's properly represented in this array. And similarly, the bias term is also a tensor, and it also contains all the biases for all the neurons in the network. So now these are basically the initial values, since you can see that here we have written row 1. So you are passing the data of row number 1 through the network, and say this is also epoch 1, right? So this row 1 you are passing. So initially you also have randomly initialized values of weights and biases. So what really happens over here? So you pass in the data for x1 and x2 for the first row to the input layer, then some mathematical functions take place in the input layer, the outputs is passed to the hidden layer, the hidden layer also imposes some mathematical functions on top of the inputs, it passes on the output to the very next layer, and like that you come to the output layer where you apply softmax activation function after affine transformation, and you finally get the probabilities. Now what do you do after you get the probabilities? You do backpropagation. Now as I said, backpropagation is the process in which you basically calculate the gradients, and then you use the gradients to tweak the values of W and B, which are your weights and bias tensors, right? So here you can see that Bragg propagation calculates gradients and then those are subtracted. Now there are many different ways in which you can tweak the values of the weights and bias tensors. Now one of the very simple ways is to basically subtract that. So this is basically the way in which it happens. So here you can see that the value of W is there in this formula, and from this W you are subtracting the gradient of W multiplied with alpha. So what is alpha? So alpha is basically a term called the learning rate. So learning rate is again, defines how fast your neural network is learning. Now there's a way of choosing a learning rate and everything that we are going to talk about again in future. So here you basically have the learning rate, you multiply the learning rate with the gradient of the specific parameter, and then you subtract that from the old one, right? So like that you have the modified values of W prime and B prime, and these are something which are going to be used in the next row, right? When you pass the next row. So again you are passing row number 2 now. You can see that x1 and x2 features have this 2 written over here. That means you're passing row 2 for row 2 values for these two features. And right now the weight and bias tensors are W prime and B prime. So now for the row 2 you pretty much again pass the values to the input layer, then it also imposes the same mathematical functions and it passes on to the next layer. So all those things which happened for the row 1, it also happens for row 2, and but this time when you use the weights and bias terms, you use the modified ones. Now there's also another thing which you should know, that is it's not actually row 2, this is epoch and row 2, right? So as I said, right, the number of passes through the dataset is your epoch, right? So say you do 10 passes through a dataset that contains 100 rows. So it is highly possible, right? So basically in each epoch you are going to pass through all the 100 rows. So maybe this is epoch number 5, right? So you are in the 5th epoch, you have already passed 4 times previously. So you are in the 5th epoch and you are in row 2. So just know that it's just not like for one epoch, rather it's for multiple different epochs. Now finally, once you are done training for all the epochs and all the rows, so basically you are at the end of the last epoch, right? So at this time you have a trained neural network ready for you, right? So now if you pass in any new value for the features x1 and x2, then you will pretty much get the probability values for the classes positive and negative. Now whichever class has the highest probability, that will be the class of that specific row which you have passed, right, for inference. So that's pretty much how a neural network is trained. So again, what is the goal of the entire training process? So this is the most important part here. So the goal is to find out the correct values of weights and biases for each neuron, right? So you have weights associated to the different edges and you have biases associated to different neurons. Now the entire goal of training the neural network is finding correct values of weights and biases. Now if you see that in a neural network, the only term that the neural network has, it's the term of that neural network specifically, then those are the weights and biases, right? Because the data point is something that we are passing to the neural network, right? The neural network only contains weights and biases, and then you have a multiple different mathematical functions, this and that, but all those mathematical functions are functions of weights and biases. So once a neural network knows what are the correct values of weights and biases, so if you pass on any new row, which is from pretty much the similar distribution of data on top of which we have trained the neural network, then the neural network will just use the weights and biases, or I should say the trained weights and biases, and it will be able to predict correctly. So this is pretty much how the entire training process of the neural network works. I hope you understood, right? But if you still have any queries, any doubts, then make sure to post them in the comment section, so maybe I can make another video regarding that, right? And talking about the gradient and loss functions and backpropagation and all these things, don't worry, I'm not gonna skip them completely. We'll talk about it in the next section, and from the next video onwards, let's start talking about PyTorch, right? Let's just see what is PyTorch, because it's been quite some time and we need to get started with PyTorch now. A lot of theory has been covered, now PyTorch is necessary, right? So yep, that's pretty much it, and I will see you in the next one.